Hello, this is your quick recap on electron configuration. So first I'm going to talk about what the periodic tells us, and periodic table tells us in far as orbitals, like where the s orbitals, p, d, and f. And then I'm going to do a few examples with you and show you how the periodic table can show us the Aufbau diagram. Instead of filling in the boxes, the periodic table kind of has all the boxes in there for us. So let's do some labeling. First, the s block is right here. Now helium, I know he's way over here on the right side, but there's a little spot for him right here. So we kind of pretend that he lives here. That's helium. And this is the S block. The P block is this one right here. P block. Your D block is the middle spot. And the F block is on the bottom. Lowercase f. Now, the periodic table also has rows, and each row has a number because those are the energy levels. Energy level 1 is row 1, energy level 2 is row 2, and 3, and 4, 5, 6, 7. Now, do be careful that this F block here technically belongs kind of in the middle. So this lanthanide goes right here, and the actinide goes right here. Sorry, my image is so fuzzy. So when we think about the lanthanide series right here is really in row 6, and my F block on the bottom, my actinoid, is really in row 7. Okay, so having these numbers go across tell us the energy levels, and having the different labels of the P, D, S, and F blocks tell us what shape the orbital's in. So, let's take it here. Today what I want you to be able to do is just be able to write electron configurations for any element, the shorthand and the longhand, and then tomorrow we'll talk about what this kind of means. So let's say I wanted to write the electron configuration for something like fluorine. Fluorine has a total of, here's number 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 total electrons. So if I start at the beginning, the first step you want to do is find your element on the periodic table, and then start at the very beginning. And I want to go 1s2. I start at the beginning and kind of go down the row and down the row until I get to my element. And that row is going to tell me the different ways or the different numbers that have to come in. So let's start. Here's my first row. I have 1, and it's in the S block. So I would say 1s. And there is 1, 2. 1s2. Now I go to the second row. This is 2s. 2s, and there are 2 boxes. 1, 2. 2s2. I move all the way across that row and I get to boron. Here's the P block. It's in row 2. So this is 2 P block, P, and there are 1, 2, 3, 4, 5, 6. 6 boxes across. But I don't actually have to take all 6 to get to fluorine. So really this should end in 2p5, because it only takes 1, 2, 3, 4, 5 boxes to get to fluorine. 2p5 would be the end. So that's my electron configuration for fluorine. So let's try one a little bit trickier. Let's go to nickel. First I'll find nickel. Here he is. And I'm going to start at the very beginning. This would be row 1, 1. It's in the S block, right S, and there are 2 boxes, 2. Go to row 2. There is 2. It's in the S block. S, and there are 2 boxes. 2. Move across row 2, and I get to 2p. Second row, so 2. P block, right little p, and then it has 6 boxes across if you count it. 1, 2, 3, 4, 5, 6. 2p6. Move to the next one. There's 3. Row 3, I have sodium and magnesium. Row 3 has 2 in the S block. 3s2. Keep going across. Now I'm in the 3p6. 3p6. Go to the 4th row. Finally, I'm in nickel's row. 4s2. And then here's where it gets a little tricky. This is technically the start of 3d. This would be 3d. 1, 2, 3, 4, 5, 6, 7, 8. 3d8. Now we have 3d8 gets us to nickel, and we're good. The row 4, although the D block is in row 4, it's not technically called 4D, and that's because the third energy level has S, P, and D. Third energy level has 3 different orbitals, just like the fourth energy level has 4 different orbitals. But it comes in at 3D because that's when the electrons did their repelling, and it kind of moved all the boxes away from where it should have been. So the periodic table actually accounts for that, but we just have to remember that this is actually 3D. This row here will be called 4D. This row is 5D and 6D. Equally as confusing, this F block here, although it's in row 6, we actually call it 4F. That's because the 4th energy level has 4 different shapes, S, P, D, and F. And this row right here, although it looks like 7, it's really called 5F. That's just something you have to remember. Okay, so let's try really kind of a tough one here. Let's go to samarium, way down in the bottom. SM. Start at the top and work my way down. Start at the top. I got 1s2. Go across the row to row 2. 2s2. Move across row 2 to the P section. 2p6. I counted 6 boxes across. Third row, I'm now in 3s2. Go all the way across. Now I've got 3p6. Now I'm in the fourth row. 4s2. I'm now in the D block, and when I would call this 3D, and if you count the number of boxes, it's 10 across. 3D10. Now I'm back in the P range, and P is in the fourth row, so 4P6. Brings me to row 5. 5S2. Now I'm in a 4D. 4D10. Move it across, back into the fifth row. 5 and P. 5P6. Now I'm in 6. 6S2. Now I'm in the F block. This brings me down to the F block. It's called 4F, and I'd have to count over. 1, 2, 3, 4, 5, 6. 4F6. So those are the longhand ones. Hopefully you can kind of pick any element you want to. I also assigned 3 elements, and the answers are up there so you can check yourself. Let me show you how to do the shorthand, because yes, this is a lot to write, and the chem gods don't like to do it either. So let's kind of make our life easier. Taking a look at this last column here, the noble gases. The noble gases have a filled energy level, so everything they've got is completely filled, which makes them kind of special. So we can kind of shorten things up. So if we want to do the shortened version for fluorine, we would find fluorine and then back it up till we find the first noble gas, helium. So its shorthand would be helium, and then we go from there. So helium, then we go 2s2, 2p5, 2s2, 2p5. This right here is a complete noble gas, so they just kind of take it out and put it as helium. Now that doesn't shorten it very much because it's fluorine, but let's go to nickel. We'll backtrack to find nickel, and now find its first noble gas by backing up, argon. Argon ends at the 3p6 spot. So this part right here is all argon. So to shorten it up for nickel, we'll go argon in brackets like that, and then end it with a 4s2, 3d8. That makes it a lot simpler. And if we look at samarium here, our way at the bottom one, we'll back it up. We're in row 6, we'll keep backing it up to xenon. Xenon ends in 5p6. So this whole thing right here is xenon. So we'll put xenon in brackets, 6s2, 4f6. That makes it a lot shorter. Now the reason they do shorthand, because really all this stuff in the lower ones, these are the inner electrons, remember? Those core electrons that are shielding electrons, that they don't really do a whole lot. They're not going to kind of be valence electrons and leave or anything, so these are the ones we really have to look at. So it kind of makes our life easier that way. There's your crash course. I hope it helped. Bring your questions on Monday.